Similarly, just raise this up, it's going to give and stand here, okay? So similarly for use case diagrams, not so much use case, but class diagrams, you'd have to form the relationships with all the relevant association arrows. So you'll bring in, your generalization if there's any, you'll bring in your aggregation, your compositions, right? And your association or your dependencies, right? So you'll bring all of them here. Whatever that has been taught in terms of relationships in UML diagram is consistently deployed. The concept, you need to understand. The usage, you need to be very careful to adopt the right associations. Similarly, in terms for class diagrams, but in object diagram, they don't show multiplicities so much. Although people would like to tweak the object diagram, but then multiplicities are not required, right? Because in object itself, you can see the multiple layouts of the number of instances that's created within the class diagrams. So if you have one to many in your class diagram, then your instances need to show one and many more other options that's available in your object diagram, okay? So this can be a simple test question. Object diagram is a type of a structural or behavioral diagram, right? MCQ, that's it, simple. You got a tip for your test that's going to come up after your break, right? If I'm going to plot that question. So what's the purpose? So the fact that object diagram is limited, so it just shows examples of your data structures. So in your analysis phase, you create class and describes the structure of the system. Then you create a set of objects as test cases to verify the accuracy and completeness of your class. So when you draw your class diagram, you want to be sure that if you were to create an inheritance of more than one type of employee in an organization, then in an object you want to show that there will be employee A, employee B, or employee A that falls under department B, right? So it gives you what I like to call examples, right, I would use it as, in database context, it will be records that you start to put in. So if you have 100 over records, your objects will denote a very big structure of multiple records, serves itself as examples of instances, right? Look at this. I know this is no doubt they're giving you the example first. They should be explaining to you what are symbols inside an object. But then, because objects are brief in, they just have a rectangle box, that's it, right? And then the most important thing is to understand what's inside the rectangle box. So let's look at this example. So you have got the class name. So in the class diagram, you'll definitely have a department. You will see a transition of a class to an object in a bit, right? So you have a class name and you can see there's a colon here. And you start with the instance name. So I like to use the normal layman term is, give me the name of a department. So basically the instance name is an example of a department. So in this case, mathematics statistics, short form will be mathstat, is an example of an instance of a department. And what is the attribute that it will carry, right? In terms that the attribute will be, so the example shows degree with the value of both, right? Now, if you were to look at the class diagram, it will be a department having 0 or many sub-departments. All right, okay? And the departments associated to your sub-department. So if you look at under mathematics and statistics, you have a generalization there, right? You have got also department, but under mathematics and statistics, you have got two types of sub-department, which is statistics and math. Both statistics and math is a type of, falls under the department, but still under the subset category of math stats. right? Okay, so it's a generalization within a generalization, right? So under that department, you have got under math, you have got applied math, and you have so you have two types of applied math where you want to put many different. So applied math, where you have got the attribute of degree graduate, and you have applied math, the attribute of degree undergraduate. So under applied math, your value attribute one will list out all the graduate program, and the other one will list out all the undergraduate. So what differentiates more will be the attributes inside. All right, the focus of all the data within the instances that you create. Okay? So let's look at an order system. Let's look at a transition from a class diagram. So if you were to look at, you have got the superclass, which is the order, right? So a customer makes many orders, perhaps, right, in this situation. And the order, generalization, normal order or special order. All right, and that order specifically is related. That order with that specific order ID is related to that unique customer. All right, so if you want to get up to object diagram, so in this case, we are looking at customer C only. All right. So customer C, you have ABC, but we are only concerned with that one unique. So if you look at that order, it's one unique customer, right? So for this object diagram, I'm only focusing on customer C, right? So if you look at customer C, you have got a type of order. He makes an order product name Q1, Q2, Q3. Oh, looks like an O, okay? So order 1, 01, 02, 03. But then you see the order IDs are a little bit more different, right? Okay, because it's unique, it's separated, right? But under order, you have got normal order, special order. So for order 1, the type of order is S1, which falls under a special order. See in object diagram is going deeper into the class, showing specific instances and differentiating them based on the attributes that signify or justify that instance. That makes that particular object unique. So more you can break up, right? So basic symbols are object names. It's symbolized by rectangle, offers the name from the object and its class underlined as well as divided with a colon. So you have to underline the instance, colon, class name, put it into a rectangle box. And if you realize most of the time, you will have the attributes listed, right? Object attributes must have values assigned to them. Hence, you see just now the example 43, 41, whatever, right? These are the unique values because it shows you the multiplicity in action. So multiplicity, many will have different unique calls to it. Okay, right? And then, of course, like I say, you can use the links, right, to connect your instances and with your association, right? Now, what's the difference between class diagram and object diagram? Which I think you can see the difference, but let's try to look at some points, right? An object diagram is a UML structural diagram that shows the instances of classifiers in models. So you build your classes, but let me create an environment that shows the classes working in action. So when you create classes that's working in action, they're called instances at a given specific time. So you might have a situation where today you will have an object diagram for customer C, tomorrow you will have an object diagram for customer D, because D didn't happen yet, right? D will only happen tomorrow. So your object diagram is rather dynamic, right? As opposed to your class diagrams, right? Object diagrams use notation similar that's used in class. Class diagrams show the actual classifiers and their relationship. So that's what I meant by having it static in classifiers and the object diagrams being dynamic as and when your operation takes place. Okay, so if you get that difference. So object diagram shows specific instances of those classifiers and links of those instances, my point just now, at a point of time. Again, today you will draw an object diagram, 10 object diagrams based on your classifiers. Tomorrow, you'll have more, depending on your transactions, right? So that is object diagram. So you can... What was that? Okay. That's not me, guys. As if I'm having some Zumba class. Somebody started shouting. Okay. Right. So, if you look at this company structure, let's try to understand more, okay? Company. An example of a company will be C. Under, you have a link here. So, you create a object under company C, where you have got D1, which is a department, and D2, which is another department. How do you differentiate them? Your attribute, sales department, and R&D. The attribute value is the name of your D2. Okay, right? So then you have got under D1, under your sales comes, right? Same instances, but you have first attribute is sales, second attribute is US sales, right? Which shows that you are multiple of them, right? Now, under your person, that's connected to department. So in your class diagram, you will have company, you have department, and you have person, right? And you have got your person, the type of category, an instance of the person is P, right? And you have got details of P. So who is P, which is part of the person classifier that falls under the US sales department, D1, you get the details, which is the attribute. And then you have something called anonymous object, right? Where if you had a class called contact information, it might not have been in the class diagram, but you create an anonymous object here to represent that particular person. So you can create a contact information of that particular person, right, and name the address for that particular individual. Not many a times anonymous objects are created, but in object diagram, you are allowed to do it even if you don't have a class call. You can still create that instance one time. All right, it's allowed. Okay? And then you have another example of a point of sale, right? Writer, all these you can run through, right? Object diagram, robot moving behavior. Have a look. These are things that you can run through later on during practical after we finish our class diagram presentation. Now, let's go to activity diagram. So now everybody knows how an object diagram looks like. What's the shape that we have? Rectangle. Instance, colon, class name, underline, associations, bring out examples at a given point of time of your class diagram happenings, right? Now let's look at activity. Now where does activity fall? Activity diagram, come back to the base diagram, falls under behavior. So behavior, you switch off, right? The workability of the system, but you look at the top level view of the functionality. Basically, tell me the flow. Just like how use case showed you, an actor, right, applies or, orders a product or performs payment, right? You want to look at top level view, but activity goes a little bit more detail where it can account on basis of time that it happens. And this is depicted in what we call iconically as how you watch people going for a swimming competition, right? You know swim lanes, right? You know swim lanes when you run, let's say, a lap of 8 contestants, the whistle blows and the fastest goes, right? And the slowest slacks, isn't it? Similarly, the fastest is going at a given time, right? He's got a timing that is recorded, right? Similarly, with the inclusion of all the actors that you defined in use case, right, you will connect all the activities based on swim lanes. So the swim lanes are separated based on the actee and the occurrence of the event. It's like a Gantt chart where you have a last in, first out. Last in, first out, that means you have to finish this activity, only then you can go to the next activity. All right? And this is all about the features, the function, the operation, the flow of events that take place inside a system. So if people were to ask you, can you draw an activity diagram before a use case? No, that's not the best practice. Use case gives you the boundary, right, of the system, top level view. The activity diagram breaks that top level view into smaller composition that actually shows the subset of data being manipulated, but still governing a common outcome of the system. So let's look at how an activity diagram looks like in Outlook. But before that, I just want to show you how it looks like this. The main Outlook, this is the first part of activity diagram. Wait, hang on. First part. This is still very raw. Swim lanes, right? You will understand the swim lanes as we come in. And there's usually an MCQ question on swim lanes. Okay, so before we go on, let's look at some. As I repeated, let's look at some points. It describes how activities are coordinated. Coordinated meaning run that process first. After that process, this process. After this, this. After that, that. So you got a 1, 2, 3. Wait, let this one come in first. So activity, that means there is a timing that's related. No doubt we are not going to control the timing, but the swim lanes will show you, and even the flow of top-down can show you. Parallel activities, right, that can occur at the same time, right, or predecessor, successor activity. On top, parallel, or successor. Follow? Right? So, typically, an event needs to be achieved by some operation, particularly where the operation is intended to achieve number of different things, but which requires, the keyword here would be coordination. So what are you doing? You're coordinating all the events, right? Now, how do you start it? Identify your candidates in the use case. So whichever actors you introduce in the use case, when you draw the swim lanes, you have to draw the actors in, right? Identify pre and post condition for use cases. Remember in use cases, we were doing all your oval stop, 1, 2, 3, 4, 5, correct or not, right? Now, in activity, you have to think, which use case starts first? Which one follows up after that, right? Which one can happen at the same time? You understand, right? So, in activity diagram, you have to start to identify them. We'll see in a bit. Then you model the workflow between or within the use cases. You bring in more complex, extended from the use case, and then you go back to your use case and check whether the boundary I have in the activity is consistent inside my use case. Follow? Right. So, this is what we call precondition. Every activity. Again, you. Again, you. Where's your buddy? Precondition. I'm watching. You always start with a black bubble in activity. Every activity diagram starts with a black bubble. This is what we call precondition. When you put an actor input, there will be an actor input here. That means in a swim lane, somebody is providing you with that particular data to initiate that use case. Okay, right? So that's why the arrow is an input. Okay? And you have an arrow here. Step 1, this is what we call an alternative or extension flow. This is a basic flow with an arrow, but you introduce this diamond if you have an alternative. So it's like a flow chart, it's like a decision tree kind of thing, right? It's like a decision table, but in a graphical form. And then you have, if true, you go to step 2. If it's true, you go to step 3. Returning, that's an alternative flow. When you take on step 3, activities happen at the same time. The black bar is called parallel activity. So step 4.1 and 4.2 happens at the same time. But no doubt it happens at the same time. Some activity diagram, you can push 4.1 up a bit. So when you push 4.1, no doubt they occur parallel, but they execute at the same time, but this one goes earlier with a buffer of 1-2 days for the second 4.2 to come in. It's launched parallel, but you have to initiate 4.1 first, and then 2 days of buffer, 4.2 can start. But you still have to put it under parallel activities. Okay, right? And then you must always end with a, look at post condition. Look at how the bubble looks in post. It's a circle with the black dot on top as opposed to the pre. The pre is a dark dot. The post is a dark dot with a extended circular. You don't do it right in the exam, you get minus marks. So you have to make sure your notations are rightfully adopted. Okay? Right. So now let's look at some examples. Modeling. So you have, I need to use this, no, it won't be recorded. So you have package. Just, this is a very simple flow. You create a file. In use case, you might not have save. You understand not? So create save is extended and shown. If you don't show it in the right, okay, so it's like sub-processes. So you do some typing, right? Now, there will be a situation that if you need graphics, you don't need graphics, move. You need tables, right? Open and use, right? Go back. Do you need tables? Open and use. Save the file, print hard copy, exit off it suite. That's it. Very simple, right? But this is the simplest form. Then we come to swim lanes, right? Now, so let's look at another example. So this is the type of question you will get in the exam. Short questions, right? Process order example. I give you the scenario. Once the order is received, the activity is split in 2 parallel sets. One side fills, the other one sends, right? On the fill side, the method of delivery is decided conditionally. What's the condition? Depending on the condition, either the overnight or regular activity is performed. Finally, the parallel activities combined. Now, in the exam, I won't tell you parallel activities combined. I will just tell you the scenario. But I will tell you these 2 activities will happen at the same time. So when I say happen at the same time, you know you have to put parallel in, okay? Right? So it is in normal layman term rather than using keywords of activity diagram, right? So let's look at this. Now, you receive an order. Let's go up back. Receive an order. The activity is split into 2 parallel sets. One side fills, the other side sends the order while the other handles the billing. So, fill in the order, send in the order, the other one parallel invoice. Okay, so it happens at the same time. But then the fill order goes into either you have a rush order or alternative. Right? If you have a rush order, you arrange for overnight as what's stated here. Right? Else, regular delivery, go back to the decision, or because after you decide which, is it an overnight, right? I will have to to handle overnight separately maybe. Is it a regular? I have to handle because I have to close it, right? And then I wait for payment to receive, right? You can have another. In this instance, even if you have another called delivery, final delivery, yeah, you can bring in another activity called final delivery, right? And then you receive the payment. After you receive the payment, you close. And then you do a precondition, post-condition. Student enrollment. Let's look at student enrollment. Okay? Very simple to understand this. Everybody pay attention. Put away your phones. Again. Yeah, he hit you very hard. A bit harder, please, Can you hit him a bit harder? Yeah. Focus, huh? Thank you. Now, precondition. Fill out enrollment forms. Right? If it's correct, enroll to university. Correct? Right? You go back, you have to refill, right? If let's say you want to refill or you want to get help, all right? So you obtain help. Once you obtain help, right, you have two situations you have. One, you need help, or you can settle with trivial issues and then you can go back to enroll. You have two options there. That's why you have got a decision making there. So whatever it is, either if you obtain, you had trivial, the last step that needs to finish up this particular site is to enroll the person to university. So what they're trying to show you is, picture perfect is fill form, enroll. But at the side, you will have situation where you'll have some issues. Right? Once you settle, you take on the enrollment, happens parallel. Now look at this. This is what I said about, although they are parallel, but there is a buffer here. So in enrollment, right, once you already enroll in university, okay, your name's already there into the university. Now the first thing that happens in all of this would be enroll in the seminar, attend university overview presentation, parallel but buffer. So while you are already enrolled in the seminar, maybe somewhere along this you are in the seminar. Then you attend the overview. While you're attending the overview, make initial action. So it all plays with cutoff timelines, because every single action and reaction in a system, right, or within a system is controlled by timelines. Sorry. Apa tu? Paper. A test ya? I'll finish in 2 minutes. I have a test the next class. You have to end now. Now, respectively in your own tutorials, 1 o'clock I will teach you swim lanes before we start the class diagram presentations. Now, why is there only 73 submissions for the agile work? If I were to click the submission, let me click. And if you can see all the names that are in red with non-submissions, all empty here, is there a valid reason that you've not submitted? Very clearly, I told you all 11:59 yesterday. So if you're not accountable for your work, you have to have a very valid reason during your tutorial. It will not allow you to submit now. So if it's no submission, it's 1 point down for you. Okay? Thank you very much, guys. I think that's all for now. We'll have to, can you all pack up fast? I want to see that boy just now. Where is he? Him. And I want to see him also. Back again. Yeah, I think maybe you want to say that to yourself. Not attentive in class. Come here. you.